Good afternoon, all of you. Today we will have a concluding lectures on this course of river engineerings. This is what the extra class what we have designed to complete these lectures. So, basically today I am going to summarize what we discussed last 24 lectures. So, we are just summarizing it, and most of the times we prepare the detailed project report or we prepare term of reference. So, today we will also discuss how we design the planning for a river training projects or any water resource projects. So, we have two components today. I will first do the revisions of the courses and what way we have tried to fulfill the course contents of river engineering, which is, as you know, it's a very vast courses considering this point of mechanics points and looking after hydrodynamic parts with turbulent structures and all, and looking after this the ecology concept. So, if you look at that way, we tried our level best to deliver the lectures with all these relevant know-how. We try to make it these lectures, which is 24 lectures, with very interesting way, the combining all these three books along with the guidelines, the Indian standard guidelines from railway guidelines and other books what we have followed it. Now, I come back to the contents what we did it. So, very interestingly we start with first week, okay. So, in which we talk about the properties of river engineerings, introductions level, the sediment transports and all. The second week we discuss about mathematical models, the basic equations starting from mass conservations, the linear momentum equations, the Navier-Stokes equations. Further, the third week also we discuss more very detailed ways how we need to have a specific energy, the critical flow, the hydraulic jumps and celerities, which is very interestingly we keeping it for the river flows, because that is what is the extreme flow what it happens during the 5 years or 10 years return period plots, which is different than the bank full discharge or lesser than that. We were technically we are highlighting this part, which is celerity part. We also discuss about the flow to wave celerity loop rating curves. Okay, these are really new things, as well as we follow these sediment transport theorems for processes in 3 lectures, and we try to give number of the case studies to get the knowledge or get the confidence of the sediment transports and all. The followed by you started the engineering aspects. Okay, that's the reasons we started with the physical river models, the bridge cover, which is more important for us today when you try to design any hydraulic structures. The scour plays a major roles like a bridge covers, the jet scour also we have included it. Not only that, the river navigations, what is more important now. It's okay. That's what we've been discussed that way. We also talk about the river training works, riverbank stabilizations, river control structure and protection structures, which is all their engineering aspect up to the river equilibriums. Now, look at these slides which really integrate the concepts what we discussed in the last 24 lectures. So, if you look at that way, the first 3 weeks we try to look at that, try to understand the flow, hydrodynamic parts with different tools like Sediment equations, the Navier-Stokes equations, even if simple specific energy concept. Then we follow the sediment transport process. Then we follow the engineering aspect, looking for bridge cover, jet cover, the river navigations, river bank stabilizations, and also the river equilibrium, where we try to give it very interesting case studies what it done in river like Brahmaputra or the Ganges systems. So that's what quite we have organized it to look at the complete pictures of the river engineering aspects. The first is modeling aspect, the physical models, followed by we have the engineering aspect starting from bridge cover, jets cover, river navigations, which again I want to highlight it. It's quite important now. Okay, so if you look at that river navigations, we have included river equilibrium, we have included, which is necessary for designing any hydraulic structures like bridge, dam structures. We try to know it how the river behaves it. That's what we consider the river equilibrium. So part of that, the river bank stabilizations, we have really have gone through more details how to design a river bank stabilizations. Looking that way, we believe that we have completed the course looking at all these angles. In this PPT, we have very details of all these components, starting from week 1 lectures. Okay, like if you look at this, the first PPTs are indicating for us how the contributors are there, what are the major projects that are there, and the modeling frameworks. Okay, so that way we have in these presentations we have all these materials what we have covered it, and I am not going through each one because we will be sharing this PPT to you. We talk about the sediment transport at the scales which is much level of the particle scales. Okay, if you look at this, we are talking about the particle scales, and then we are talking about the all this process what is happening from rolling, sliding and slidations, followed by we have a gross characteristics how these the shear stress distribution changes it. So I am not going again to repeat this part, but what I am just visualizing is that what way we have did this course in different lectures. If you look at these ones, river bank stabilizations, how this process happen, the secondary currents, the riprap failures, bank failures, design of rock riprap, shear stress methods, velocity methods, riprap filters, and the factor affecting it. So if you look at that way, we have really covered very interesting components. Okay, so design of riprap, the failures, the process, and also the factor affecting it. That's what if you can look at different river bank drainage systems also. So if you look at that way, the full concise way we have presented the things which you will get it from these presentations materials, but that's what we have covered it. So looking that way, I can say it like another is river bank stabilizations. I think you can see that what type of bank erosions protections work, starting from very expensive to the locally river bank protections like the vegetations, the Gabion mattress, articulated concrete mattress, all we have discussed it. That's my point. It that the course, if you look at that, is a full fledged from these the presentations. You can really understand it. But let me coming back for another few minutes on the planning design of a river training works. So whenever we design a river training works or planning for a river training work or water resource or projects work, we go phase wise. We go the phase wise. The first phase is the preparations phases. Okay, first part is the preparations phases. That means you have to look at the data levels, socio-economic data, the resources, what is there, agriculture, the fishery, the industry, recreations, and what is the present systems, okay, in terms of hydrology, morphology, water qualities, ecology, present infrastructure, all you need to do it. So that's what is quite interesting. So when you do any water resource projects, even if riverbank protections, please don't look it as isolated projects. Always you try to get a data in your project reports about hydrology, the morphology, water quality, the ecology and present infrastructure, because that what will give it very much the complete informations about the projects. So the projects should have all these informations from hydrology, morphology and the water quality, the ecology. Some of the primary data set you can collect it, some of the data from the secondary data set can be used it. That is what will be the first points, the primary and secondary data you can, then it comes to the analysis part. Okay. That is what inspection phases, that means you collect the data from the different sources. And today's for the river engineering we have a lot of global data sets, like for example Google Earth, lot of global data set about the hydrologies are the available. So those the data we should analyze it at the inspection pages, go to the field, interact with the first level of the stakeholders, the people who are there in the riverbank and protects riverbank or the water sets. So if you look at that, these phases, the inspection phases matters lot. How do we understand these the present problems from a very smaller scales where you are implementing to the river scales, to the basin scale. That's the reasons whenever we prepare the detailed project reports, it should include all the components. Otherwise, as I discussed earlier, it's a very difficult if you prepare a project with a just looking at the localized conditions, that's what will be very difficult. So now let us understand that whenever you prepare the detailed project reports, it should be complete in terms of hydrology, the morphologies, water surface qualities, all the things components should be there. That's I will show it that. So the basically it is have a inspection pages and we have a lot of analysis tools. You can do physical modeling, you can do river modeling, mathematical modelings, or you do the data analysis. So the basically you do both the things. Okay. Inspection page data collection as well as do the analysis, then you commit to a particular strategy, okay, particular type of river bank protection work, river divergence work. That what has to create a series of scenario. Okay, it's not to be fixed that this is what will be implemented, this dam will be implemented. No, we should commit a series of the solutions for these problems. And that series of the solutions can be economically to be evaluated, the environmental impact assessment to be done it, so that the detailed project report should indicate very clearly that whoever developed the DPR, he has considered all the aspect of the problems, he has prepared the different management strategy or implementing strategy. For each implementing strategy also it has done by socio-economic analysis as well as the environmental impact analysis. That's what the present area we are looking for a river engineering specialist. They should work on this level. That is the reason this course is developed considering this hydraulics to the morphology, and also we try to include the ecological aspects. That's the idea behind this developing this course. Now if you look at one of project planning from of the reference, okay, that's have a first step, the collections and the review of available data. That's what is necessary first. First we should plan it, what are the data is required it, and where is the source of the data. And we can see the secondary data availability, the primary data availability, that what we can design it, what type of data you will call it. That's what is the like a details existing river networks, nature, extent, adequacy, validity, identifying the data gaps. What are the data gaps? We cannot think it that whatever our expectations level of the data, like for examples maybe 100 years river morphology data may not available to us. So we should know at the very beginning what is the data gaps are there. Then we start the collecting of the data. Like as I said it, we should collect the data in all these forms. You just look at the topography, geology, geotechnical, hydrology, hydrogeology, land use, land cover, irrigation and command area, navigations and the environmental, socio-economic, power and existing hydraulic structures. So, if you look at this way, it makes it very interesting that we should not look at the problems very sectorally. We should collect all the data. No doubt there is a issues of the scale issue, the accuracy issue, but whenever you prepare the DFIRs, all the things should be highlighted, even if there is a scale issues, or even if there is a accuracy, the problems with the accuracy of the data, that should be highlighted, because there is no report is available in, even if in the developed country where all the data availability is there, but we should consider all the data, the scale issue, the accuracy issue, all we should highlight it. Data gaps issues also should be highlighted. So, that's what is gives a more transparent. Like nowadays, whatever you prepare the DFIRs, it's available in the internet. So, that means your DFIR should contain all these components, otherwise it's a halfway DFIR will be there. The second part, if you look at that, the preliminary planning and designs. Okay, so you look at this planning and design, database preparations. Okay, so when you prepare the data, you got the data, then you prepare the data like the platform like geographical information system. So, platform like any database systems like Microsoft Excel or Access, you prepare a uniform database. That is what's necessary, because when you do a planning is not a one-way shot. We have to have a lot of interactive way to look at the data against. So, the data planning, database management, that should be very proper with a GIS specialist or with a database specialist. He can design depending upon our data requirement, the scale of the study is necessary. That what is to look at the data like geomorphology, geology, hydrogeology, surface water body, populations, any other spatial and temporal data sets. So, that's the reasons the GIS must play the major roles for us or any database to be prepared it in different. Mostly nowadays we use the GIS platforms to prepare the database, the preliminary database preparations. Then you go for the survey and the investigations, where if you look at it, we do river survey, we do reservoir survey, command area survey, soil survey, intake and out. So, you need to go to the survey and basically you do first topography, then geological geophysical investigations, you do DEM, drainage, groundwater assessment, soil cover, bedrock profiles, then you look at the design aspect, prepare the maps or the layout for this. So, that what you go to the field, do the survey and collect this data. Then it is coming it water resource assessment studies. So, what we do it, I either requires assessment using the hydrological data. That is the reasons all these steps are there. I am not going details here. So, first is whatever data you collected, many of the times where you have the site, you do the intervention at that locations, you do not have the data. So, how you can take the data from other basins or the upstream locations and downstream locations, but the field data is necessary to do the analysis to know it, what is the water resource availability, the discharge availability. Those things we should do it. Same way also we target to do this numericals, mathematical or physical modeling assessment. Okay. That the assessment you will cover it, developing the models and assessing the plot controls, assessment the sediment and also the groundwater recharge. So, what I am to tell is that all these components we should look at, that how we can do the physical models as well as mathematical models. So, nowadays many of the times we use mathematical models, which is available today's, but the physical models also plays a major roles when you design a major projects. Then it's coming it that you will have a next assessment is engineering and the design studies, which include the hydrologies, meteorology, hydrogeological assessment, engineering assessment. So, type of river bank protection, type of dam projects you are looking at, geological and geotechnical assessment. Then it's come it very interesting things, the EI, EMP reports. Okay, you have to create, we have to assess the environmental impact assessment, environmental management plan, those things should be there in the DPRs. Here I am not going very details how to prepare the DPRs, but the EI or environmental management plan, which need to have another environmental specialist to look at this component. The guidelines are available in Ministry of Environment and Forest, and those reports can help us to assess the environmental impact assessment and environmental management plan. So, without this your report is not complete. So, that is what you can look at. Then it is coming at the engineering implemented stage, starting from constructions planning, manpowers, preparations of project operational philosophy, socio-economic aspect, benefit cost ratio, financial and economic analysis. So, any detailed project reports, all these 11 steps should be there. Very detailed should be there to look at that. Most of the DPRs also give a different chapters. So, each one is they give a different chapters, they discuss it, because DPRs give a strength for the projects, how to implement it, what are the problems exist on this. So, that the preparation of DPRs play the major roles. That's what I am to highlight it, and your knowledge on river engineering, the environmental, that's what is necessary to include it. So, let me I come back to one of study what we have did it for see what is showing the structures of the DPR. Should have feasibility report, socio-economic studies, R&R, topography study, geological, geophysical investigations, geotechnical, hydrology, modeling studies, details layout and the time schedules. These are chapters should be there, okay, and that is what will make the DPR will be more strength or more technically strong. So, if you look at that, the same way we prepare the DPR for cumulative impact assessment for proposed hydropower projects, determinations of river basin carrying capacity, landscape level biodiversity management plan, which is there in Ministry of Environment Forest web page. You can always visit it and get it these reports. Here I am not going very detailed about that, but that reports contains all these parts, okay, how to prepare a DPR consisting of environmental impact assessment, basin carrying capacity and landscape level biodiversity management plan. So, if you look at that, that is what the three aspects of the projects are there. So, that what my point is that we as engineers we have to plan the things very, all these aspects of these projects we should consider it, otherwise the project does not stand technically sound. So, I am not going details about these projects which will be available in this PPT. So, I am not going more details, but because this is what just to have a introduce you that how to prepare the DPRs. Okay, more details you can go through it. Like for example, if you look at these graphs, we can give in very details that how does the field photographs, where the flow depth, and this one is showing the carrying capacity. So, if you look at that way, the presentations of the DPR also matters it, how you compile the data and present the data. That's what also matters it. So, because DPR is documents which can be understood by the many stakeholders, starting from the people to the top bureaucrats who can understand the things. So, that is the reasons the data analysis and all the things, graphical presentation, the illustrations should be very clarity. So, that should not have a issues on that. So, that is my point, because as you know it, the water resources projects are always have a multi stakeholders. So, like for example, individual project impact assessment, here if you look it, we consider physical environment, biological environment, human environment. So, all the components should be there. No doubt there is a certain assumptions we have, certain qualitative measurements are there, some are the quantitative measurement, but the project report should contain all the components and also should highlight the assumptions, the limitations of the data or the analysis. That should be there. That is what my point to highlight it. So, same way I am not going to more detail about these projects. I wish to just to give you the feeling that when you prepare the project reports, it should contain all these components, at least the 11 points what we have discussed it. With this, let us conclude these concluding lectures, which really we have enjoyed developing these codes. But let me I quote it, quote from Dean Axon, that we cannot argue with a rivers. Okay, it is going to flow. You can dam it off, but put it all useful purposes. You can deflect it, but you cannot argue with it. So, please try to understand that. That is what is our motto, to develop these codes, and you really could have enjoyed these codes. And before ending this course, I would like to thank my PhD scholars who has really put a lot of efforts to develop these course materials. Mr. Chandan Pradhans, Mr. Ketan Nandi, Mr. Ridik Kakoti, and Ms. Lashyamai Sao. With this, let us conclude today's lectures. Thank you.